Okay, so we're looking at the intersection point of these two polar curves. I have a lemmason facing to the left, and I have a circle of radius 1. I have three intersection points, this one up here, this one over here on the y-axis, and this one down, excuse me, the x-axis down on the y-axis over here. These clearly look like pi over 2 and 3 pi over 2, and this is pi. These two dots here don't really mean anything. They're just kind of default from the graphing software I was using. I was too lazy to delete them, as well as your x and y axes being highlighted. That doesn't really help me. So I'm just going to set these two equal to each other because they're both equal to r, pretty straightforward. So I get 1 minus 2 cosine theta is equal to 1. I bring the 1 over, so I get negative 2 cosine theta is equal to 0. So cosine of theta is equal to 0, so theta is equal to pi over 2 and 3 pi over 2. Since this is a radius of 1, I get 1 comma pi over 2 and 1 comma 3 pi over 2. But I also have this other point over here by inspection. Just by looking at the graphs, I notice that they intersect over here at a radius of 1 and an angle of pi. So I just find the quickest way to write this is 1 comma pi. So it just goes back to the unfortunate thing with polar curves is that's why it's imperative that you graph them, because sometimes you'll find solutions in the graph that wouldn't otherwise be found algebraically. So you have to, just by looking at the graphs by inspection and finding any additional points that don't clearly show up by using your algebra and trigonometry skills.